Yes, good afternoon.
Good afternoon.
So we are starting our lesson of separating mixtures. Our first mixture is a mixture of salt and sand. We have mixed the mixture we have put the mixture in a beaker. And I want to add distilled water. What is the reason of adding distilled water? It is to ensure that the salt dissolves living what? Living sand. I don't have a stirring rod, but I can use a spatula to stir. You stir the mixture properly and thoroughly. That's how you stir. Why are we stirring? So that the salt can dissolve. Okay?
Yes.
To make sure that the salt has dissolved. And you take time while stirring, not just jump into it. Now, as I can see at the base, most of the salt has dissolved, and at the bottom I have sand. I can take a filter funnel, this one is called a filter funnel, and a conical flask. This one is called what?
Conical flask.
What about this one? So you fold your filter paper. This is how you fold your filter paper. You fold it twice. That is circular. You make it a semicircle. Then you form a quarter of a circle. And then you open one side of the semicircle, and then you place it in a filter funnel, as you can see. Okay?
Yes.
And then now you fit it in a conical flask. Then the mixture that you want to separate, you put it there, and you give it time to separate. And as you can see, we can also decant the mixture, and I want us to see the difference when it comes to decantation and filtration. So decantation, I want you to see the difference between decantation and filtration. Are you seeing any difference between decantation and filtration?
Yes.
What is the difference? Yes, at the back.
The filtered water is clear than the decanted water.
Very good. Plump. Okay. The substance you obtain after filtration in form of liquid is clearer than the one that you obtain after decantation. That is the difference. Now you can see you have been left with your sand here. This is sand. Put it. It's just sand. There is no white color. It's sand. So have you seen the difference between decantation and filtration?
Yes.
That is good. Next one we are going to demonstrate is use of amalgamates. Use of
Amalgamates.
So when you're using amalgamates, what do you look at in your mixture? You look at the mixture and you confirm whether there is a substance that is what? Magnetic. And for this separation, we are going to use iron filings and sulfur. What is the color of sulfur? The color of sulfur is? You see the color of sulfur as I put it on the filter paper. So what color is this? Some are keeping quiet. This color is? Yellow. Very good. Very good. Sulfur is yellow. Also, I put iron there. I put iron. Can you see iron is there?
Yes.
What is the color of iron? Iron is gray, not black. Does iron look like your hair? The color of iron is gray. Then you mix iron and sulfur completely. And then you spread the mixture on a piece of paper. Okay? You spread the mixture on a piece of paper like this. Do it this way. After spreading the mixture on a piece of paper, as you can see here, all you do is you do what? So after spreading your mixture with that, you just take your magnet and you pass it slightly above the mixture. You pass it slightly above the mixture. This is iron. Can you see the iron in the magnet?
Yes.
The sulfur has been left on the surface of the filter paper. Right?
Yes.
And that method of separating mixture is called magnetism. Where you're using a magnet to attract the substance which is magnetic. As you can see, sulfur is not magnetic. Sulfur is left on the filter paper. What is the color of sulfur?
Yellow.
What is the color of iron?
Red.
What is the color of the mixture? Yellow, gray. Yellow showing the presence of sulfur, and the gray showing the presence of iron. That is another way of separating mixtures. Another mixture that I want us to prepare, I want us to train ourselves to prepare solutions. And when we are preparing solutions, here I have wood ash, I have a conical flask, and I have a plastic beaker. Okay?
Yes.
So we are done with that one. Now, before we go to preparing of a solution, I want us to look at the surface of the filter paper. On the surface of the filter paper, we are left with a solid substance. Can you see a solid that is left on the filter paper?
Yes.
This solid is called a residue. It's called
A residue.
residue. When you carry out filtration, the substance that is left on the filter paper is called a residue, and the substance that you collect in the conical flask, the colorless liquid that you are seeing there, is called a filtrate. It is called what?
A filtrate.
So during filtration, we have a residue on the filter paper, and we have a filtrate in the conical flask. Now I want us to prepare a solution. This solution is a solution of goulash. So the first step is you must have a clean beaker. It can be plastic or maybe glass beaker, and you put your goulash. You can put as much as possible. Mine is more than enough, so I can divide it into two. And then I add distilled water. So what is the color of goulash solution?
Red.
Yes, you can see it is gray. Can we obtain a clear solution from goulash solution? By doing what? By carrying what? Filtration. Okay? If you want a clear solution like the one that you have obtained from the other experiments, you carry out filtration. So, take a filter paper. You know how to fold a filter paper?
Yes.
And those who didn't check the first time, we can check it for the second time. We make a semicircle. Start by doing what?
Making a semicircle.
Make a semicircle. After making a semicircle, we fold it again to make a quarter of a circle. A quarter of a circle. And then from there, you open one side, okay? You open one side. That's that it looks like. And then now, you fit it in a filter. This one is called a filter funnel. Then you put them in a conical flask and you see that it is working very nice. This one is called filtration. As you can see, we are getting a very clear what? Not water, filtrate. It's called?
Filtrate.
Filtrate. And add some more. So that's why we say that in chemistry, students should be very careful when carrying out an experiment. Now, can you see what is happening here? Yes, we have the filtrate being collected in the conical flask, and on the filter paper, a solid will be left. What is the name of that solid? Very good. So the solution that we have obtained here is called wood ash solution. Okay? Yes. It's called
wood ash solution.
That is the name of the filtrate which we have collected in our conical flask. That is all about preparation of a solution. See, if I ask you to prepare a certain solution, you will not be able to prepare? Yes. Will you be able to prepare?
Yes.
If I want a solution of soil, will you be able to give me that solution?
Yes.
Very good. Now next, we are going to carry out sublimation. We are going to carry out what?
Sublimation.
We will be carrying out sublimation. And sublimation, it is a method which we use to separate substances whereby one of the components of the mixture should be able to change from solid to vapor. Should be able to change from solid to what?
Vapor.
Very good. And in that case, I have a substance which changes from solid to vapor directly. That substance is called iodine. Substance is called
iodine.
Very good. So we are going to separate a mixture of common salt. Common salt is called sodium chloride. Common salt is called
sodium chloride.
Very good. So we are going to separate sodium chloride and iodine mixture by use of a process known as sublimation. Sublimation involves heating the mixture until one of the substance forms the vapor, and that vapor is cooled and condensed. The vapor is cooled and condensed to form the solid. We are going to demonstrate it. So I use the two beakers. I use the first beaker to hold water. This one will be holding the water, and the work of that water is to cool the iodine vapor. Is to do what?
Cool the iodine vapor.
Anyone who is asthmatic around here? Somebody is asthmatic? If you are asthmatic, raise up your hand. So can you get us? Simama hapo kwa mlango. Somebody else who is asthmatic? If you have breathing difficulties, so you can see the mixture. What is the color of iodine? What is the color of iodine? Iodine is not white. White is common salt. Iodine is black. Iodine is
black.
Yes, the black color you are seeing in that mixture is iodine. And the white color you are seeing in the mixture is sodium chloride. You should not go very far. What you require is you should be very careful to make observations. We have the beaker with the mixture at the bottom. We have another beaker with the ice cold water on top. Are you seeing something happen?
Yes.
Which color are you seeing? Very good. You're seeing purple color. You're seeing purple color. So what is the color of iodine vapor? Very good. Iodine vapor is purple. What is the color of iodine solid? Iodine solid is black.